Before we get started, I have a quick favor. I've been self-funding the Finding Genius podcast for 5 years now. I've done over 3,000 episodes. And as you can see on YouTube, we're up over 1 million views on the channel, which is fantastic. The next thing I really want to push on is to get up to 10,000 subscribers. Because once we do, we'll be able to put a donate button and we'll be able to solicit donations to help keep the podcast running and to also get the Finding Genius Foundation moving along. We have a big project studying anxiety, depression, and PTSD and working on a product to help people overcome these problems because I've seen them explode recently after the last 2 years of the whole virus situation. So if you would, please subscribe to the podcast. That would help us tremendously. Give us a thumbs up and check in the description for Buy Me a Coffee. It's about $5. If you could buy me a coffee, I'd really appreciate it. It would help keep the channel going, and I love coffee. Thank you. Increased stress is linked with teeth grinding and clenching, which causes poor sleep, jaw pain, and headaches. But did you know that 1 in every 4 adults grind or clench their teeth while they're sleeping? A Remy custom night guard can protect your teeth from grinding and clenching while saving you hundreds of dollars compared to getting one at the dental office. Use code GUARD20 for 20% off your order. Visit shopremy.com now. SHOPREMI.com. Before we get started, I have a quick favor. I've been self-funding the Finding Genius podcast for 5 years now. I've done over 3,000 episodes. And as you can see on YouTube, we're up over 1 million views on the channel, which is fantastic. The next thing I really want to push on is to get up to 10,000 subscribers. Because once we do, we'll be able to put a donate button and we'll be able to solicit donations to help keep the podcast running and to also get the Finding Genius Foundation moving along. We have a big project studying anxiety, depression, and PTSD and working on a product to help people overcome these problems because I've seen them explode recently after the last 2 years of the whole virus situation. So if you would, please subscribe to the podcast. That would help us tremendously. Give us a thumbs up. And check in the description for Buy Me a Coffee. It's about $5. If you could buy me a coffee, I'd really appreciate it. It would help keep the channel going, and I love coffee. Thank you.
Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast. I have Daniel Wells. He's an associate professor at Auburn University in horticulture. So we're going to talk about hydroponics and his other research. So Daniel, thank you for coming.
Yeah, thanks for having me, Richard. Appreciate it.
If you would, tell me a bit about your background, how you got interested in what you do, and then let's talk about your current research.
Yeah, sure. So I have actually a long history in sort of agriculture and research. So I actually grew up on a research station. My dad was the director of one of the outlying units, the state of Alabama. It's down in what they call the coastal plain wiregrass region, which is the southeast corner of the state, and 600-acre farm. Sort of run like a farm, but it's a row crop research takes place, and there's other units around the state as well. Anyway, grew up down there, so I've been in agriculture my whole life, but decided that sort of row crops weren't for me, and went to college. Came to Auburn University actually as an undergrad, and did pre-med. Worked at a hospital for a little while, decided that wasn't for me, and I fell back into horticulture because I had done landscaping in high school and really sort of fell in love with it there. And then I went to grad school and ended up going to LSU for my PhD, and then ended up back here at Auburn in 2014. So, that's sort of the sort of long and short of it. But I got hired to do, research and teaching. I'm a 60% research, 40% teaching appointment here in the department. And my research program has sort of evolved over the years, but mainly it's controlled environment agriculture. That's hydroponics. I do aquaponics. I lead a project in aquaponics as well. And then I teach classes that are sort of revolved around the same topics. I teach a hydroponics class, a plant nutrition class, an advanced controlled environment class. And then I also teach organic gardening, which I teach online. It's a lecture-based course, and I teach it every semester.
So what's your current research about right now?
Well, we have lots of research projects going on. I lead our aquaponics project, as I mentioned previously, and that's a team with, goodness, I think we have 8 researchers on that, several grad students and research associates. I have work that I'm doing in sort of, I guess you would call it traditional hydroponics. We also operate a couple of vertical farms on campus. They're shipping container models. And then most recently, I'm involved with a rooftop garden on top of a brand new building here on Auburn University's campus that we're really excited about, called the Rain Culinary Science Center. And so I'm sort of in all those fields. My research interest, I suppose, mainly is looking at controlled environments and I guess urban agriculture coming into the Southeast. The Southeast has a unique climate. It's, it can be really hot and humid here. And most of the controlled environment stuff, think about greenhouses and vegetable greenhouses, those technologies were developed in the Netherlands first, and then they, sort of were exported to Canada. And now they're kind of coming down into our part of the country, and we have sort of unique challenges. So we're looking at those challenges. That's part of what my research program is focused on. And then when it comes to aquaponics, it's just developing the technology and trying to make it what we call sustainable, which means obviously environmentally sustainable, but also, profitable.
Well, I'd like to ask you, hydroponics versus soil-grown crops, have you or who has done a nutritional analysis of the differences? Or, in a greenhouse versus outdoor? Who's done that?
Yeah, that's a good question. I think that would be a difficult study. A lot of times, the way I explain it to people is, one thing you have to keep in mind is that when we're growing, and I'll tell this to everybody that I teach courses and when I give talks, it's like when we're growing, let's say tomatoes, there are 4 main crops that we grow in greenhouses worldwide. It would be tomatoes, peppers, cucumbers, and lettuce. And I mean vegetable wise. Now we can grow a lot of different things in greenhouses, of course. But when you're selecting those types of vegetables to grow in greenhouses, you select greenhouse varieties. In other words, there are tomatoes that are specifically bred and selected to be grown in a greenhouse environment. So unless you wanted to compare that directly to a field grown tomato, it'd be sort of hard. There's some other challenges there as well. But I would say by and large, what you're doing in a greenhouse and in a controlled environment is you are sort of optimizing the environment to produce a high quality yield and high yields as well. And of course, that can happen in the field as well. I think the main thing about nutritional value is probably going to be how long it can stay on the plant. So the more local the produce, the fewer miles it has to travel, the higher quality and higher nutritional value we'll have.
So what are the trade-offs? Like, a lot of them are probably obvious, but what are the main trade-offs between hydroponics and soil growing?
Okay, yeah, that's a good question. So, when I say hydroponics, I almost mean it interchangeably with greenhouse sort of vegetables or indoor. And so we're talking about the trade-offs between greenhouses and field grown. So there's lots of trade-offs. So one obvious one would be that it's more expensive to grow in a greenhouse. You have the infrastructure that has to be in place, and typically they're controlled by sort of really high-end computer control systems. All that is a high capital investment, and you also have typically more expensive seeds and materials, even beyond just the structure itself, but also the substrate that we grow in, and or the seeds that you purchase, or the systems that sort of are in the greenhouse. So that's one thing is cost. So it's less expensive typically to grow in the field. But the benefit then would be that you have some measure of control over the environment, and you're able to manipulate that environment. So like I mentioned, for the Southeast, one of the things that we probably don't fully understand just yet, because the greenhouse industry is so new in the Southeast United States, at least large scale, is, we have high heat and humidity, and we're always balancing the trade-off between light and temperature. So we want to have as much light coming to the crop as possible. And some of that light is going to be reflected by the covering of the greenhouse. So we want to maximize light transmission. But we also have the greenhouse effect. So we're accumulating heat, and we have an optimal heat level. So that's a trade-off. So it's always sort of balancing. We want as much light as we can get, but we don't want all that accumulated heat. And I would say that would be one downside compared to a field production. So in other words, it's more expensive to grow per unit in a greenhouse. and you have more control. And then I would say on top of that, every layer of control that you have less and less room for error. So I think about this with vertical farms, where you're fully controlling the environment. When you have full control, that means that any mistake you make or anything that goes wrong with the system leads to really bad outcomes. That's another trade-off.
What about the different hydroponic systems themselves, like flood and drain versus like thin film, continuous water flowing, deep water culture, et cetera? Like what do those look like in terms of trade-offs?
Oh, yeah, that's a great question. There are several different types of systems. And I would say one decision to make is what type of plant do you want to grow? If you want to grow let's say a leafy vegetable like lettuce, you have two main options. You can float, in other words, deep water culture or floating raft, or you can have NFT or nutrient film technique. There's benefits to both. I would say that nutrient film technique offers some advantages because it's more ergonomic. In other words, it's sort of easier to manage in some ways. You don't have to bend over all the time. And you can do this with deep water as well. You can take the entire unit into a nice, cool place to harvest. But the trade-off is that you're constantly having to pump water. And we've done both. We've done nutrient film technique and deep water. And I would just say for my money, deep water is a more buffered system. It is less prone to major problems. I've had pumps go out on an NFT system before, and you'll lose your crop immediately. Essentially, one day without a pump spells disaster. The other thing is that the deep water systems are typically less expensive to construct. You're just, building a tank and floating rafts on top of it. Whereas with NFT, they can get relatively pricey. So that's, sort of one trade-off or comparison. And that's if you're growing leafy greens. Then if you want to grow vining crops and fruiting vegetables like tomatoes and cucumbers, then you have to go in a totally different direction. You're not typically going to do nutrient film or deep water there. So you have different options there as well.
Remy night guards are designed for comfort. Remy sends you an at-home impression kit and has a team of in-house dental professionals to make you custom, comfortable night guards that you'll forget you're wearing, all for 80% less than the cost at the dental office. Visit shopremy.com to get yours now and take an extra 20% off your order with the code GUARD20 at checkout. Remember, that's SHOPREMI.com.
What about flood and drain? Does anyone do that? And what would be the trade-offs there?
Yeah, flood and drain. Flood and drain works really well for certain types of crops. I've seen it more for floriculture crops, but also we use flood and drain when we're producing seedlings that are going to go in our vertical farm. It's actually all integrated to the same unit. And I like flood and drain. I haven't seen it on a commercial scale for, I guess I would say finishing the crop. We typically were floating lettuce, let's say, and you're constantly in that floating on top of that nutrient solution. I don't think that flood and drain would be ideal for that situation, but definitely it works really well for floriculture crops and then seedling production.
Well, why? Why would it work well in some areas and some not?
Yeah, that's a good question.
I know, like in deep water culture, the roots are not getting, you got to aerate the water, but I would think they're getting a lot less oxygen than if it's flood and drain, flood, and then it drains away.
That's right. That's
I
right.
know there's not as much contact time with the nutrients, but, there's got to be some differences there.
Yeah, so the contact time with the nutrients is one thing. All right, so to your point, when you flood it and then you drain it, that's where when it drains, that's when the plants are able to breathe, and get oxygen. But you have to have some sort of structure for them to rest on. And so when it's a floating raft, they're literally resting on top of the water, so you can't drain it. You'd have to have some extra material there for them to sit on. So with our seedlings, they are in what we call flats, and they're in, trays and plastic flats, and that's kind of holding them in place. So I don't think that there's certainly you could do it. I think it's just cheaper and easier to float them.
Yeah, I see why, because with flood and drain, you have to have them sit in pats with media, poke and core or whatever it is.
Yeah, you'd have to have
drains out, like you said, it doesn't collapse.
That's right. Yeah, I hadn't thought about it that way, but that's typically I see it on a small scale for seedlings, and then as you grow them up. Think about if you had a large commercial greenhouse. I've seen greenhouses where it's several bays, and it's the entire floor is nothing but a large tank, and it gets you have floating rafts. So that would be a lot of substrate that you'd have to purchase that would be extra.
I see what you mean. Makes sense.
Yeah.
What about the microbiome near the roots in hydroponics versus soil? Has anyone looked at that?
Yeah, so that's an interesting question. There's a lot of there's a lot of interest in this, and I would say that there is a misconception out there that hydroponics is, quote, sterile. Certainly not sterile, but it is closer to sterile, I would say, than a soil-based system or even aquaponics. So aquaponics is where you have fish, you're feeding them a high-protein diet. Typically, they produce waste and then use bacteria to convert that waste into usable nutrients for the plant, so on and so forth. And to me, aquaponics shares the same sort of infrastructure with hydroponics, but the way it behaves is much more akin to a soil-based system. And so I think there's a lot of interest, it seems like right now, and I put a couple of proposals into the USDA on this and haven't gotten funded yet, but we keep trying and looking at the microbiome, even though I'm not an expert at that, but kind of building a team to look at that, looking at the microbiome in these soilless systems. And what we're really interested in is comparing aquaponics to hydroponics. The reason being because they share the same sort of underlying technology, but the solution, the nutrient solution itself, whether it's fish effluent or hydroponic nutrient solution, are very, very different. And we can grow the same species of plants. And so looking at how the microbiome changes between those two systems, I think will be very interesting. And I know there's a lot of research out there currently looking at that. There was a great review paper in 2018 by some researchers at Wisconsin. I'm trying to remember their names right now. I think it's University of Wisconsin. And they looked at some of the work that's been done on microbiome. So there's definitely a lot of momentum in that direction. But as far as those comparisons between soil and soilless, that gets a little tricky. I think it would be, for us, we're sort of interested in that aquaponics versus hydroponics from that perspective. Because on paper, we've done aquaponics for several years now. On paper, we have it looks like nutrient levels wise that it wouldn't compare well to hydroponics, but then our yields are good. And so we sort of go, how does this work? There's microbial activity for sure that plays a role.
Well, you can still have a high yield, but maybe low nutritional content. I don't know. I don't see how the yield would really impact it, When I say yield, I mean, what I really mean is marketable yield. So I would say that I would say that the nutritional aspect of let's say tomatoes, for instance, if I grew tomatoes in a hydroponic system and I grew the same exact sort of cultivar or variety of tomatoes and I grew it in an aquaponic system and I got similar yields, when I say yield, I mean marketable, right? So it's not just that I produced X pounds of tomato fruits. It wouldn't be not the best term for that. I really mean marketable yield. Well, like taste tests, I've tasted, various fruits that are organic versus not. They're very different tasting. I've seen some tomatoes that you eat them, they taste like nothing compared to like a tomato,
Oh, I see what you mean. Oh, okay. Yeah. Okay. So that question is a very good question. I think that if you're managing your system properly, you can get the right balance of, let's say tomatoes, for instance, you can get the right balance of sugars and acidity and, depending on how it's grown. But I would say I've definitely tasted field-grown tomatoes that weren't any good, and I've definitely tasted hydroponic tomatoes that weren't any good. And so I think that what's most important from a quality perspective and probably therefore nutritional perspective from something like a tomato is how long can it stay on the plant? How well is it being managed? How close to the consumer can you get it? So a lot of those tomatoes that you get in the stores, they've been picked hundreds of miles away, what they call mature green. They're shipped on a truck, and it's a fantastic system for getting food into lots of different places, but they'll be shipped on a truck long distances, and then they're sort of ripened in these chambers with ethylene. And there's nothing dangerous about it, but they're not high quality. And so I often ask my students, I say, hey, do you like tomatoes? And about half the people will raise their hands if they like fresh tomatoes. And I always say, it's possible that you've never had a really good tomato. And that's certainly the case for me. I wasn't a big tomato eater until I started eating some really good tomatoes, and those have come out of our hydroponic and aquaponic system. So I think it's doable. You just have to manage them properly and really spending time on the plant for those fruits and ripening and accumulating those sugars and acids is really important.
And again, I know you're not a biologist, but in terms of the microbiome, if you have deep water culture, if there's going to be microbes there that have to be able to live in the water. If you have thin film, you could probably have more aerobic bacteria, so you'd have different ones, and soil would be still radically different.
Oh, I see. Yeah, I've wondered about this. I think that, the plant roots are part of a living organism. They're actively respiring. So they're releasing carbon dioxide and taking in oxygen, and they're floating in water. And so you have to look at the dissolved oxygen content. You can have root death if your, dissolved oxygen content goes below a certain level. And that certainly happens. But we can, you mentioned aeration earlier. We don't directly aerate in our systems. We recirculate water and it gets enough oxygen in there. But I think that you can support microbial life. The microbes that are sort of associated with that rhizosphere can be supported at those oxygen levels as well. Because I know that they've isolated, not myself, but other researchers have isolated plant or rhizosphere, bacteria from these hydroponic systems. They do exist. So in that way, like I said, there's certainly beneficial microorganisms. I guess the question is, are there as many in a hydroponic system than there is in a healthy soil? No, I would say definitely not. But can you get high quality vegetables in a hydroponic system? Yes.
Okay. But in your observation in the literature, there's not really much, or you don't know of anyone that's done this experimentation?
Well, I wish I could go back before we started this conversation and look it up, but there are people interested in this area. And to be honest with you, I wrote a couple proposals a couple of years ago and kind of dug into the literature then, but I haven't since. I feel certain that when we get off this call, I could go look up a paper that's going to be perfect for this conversation. So I would just suggest that listeners would Google Scholar that. But yeah, there are people that are certainly interested in this. I think that the aquaponics questions about microbiomes are really interesting because they kind of help isolate what's going on right there around the roots without the complication of a soil and all different types of soils. In other words, by studying a soilless system, and this is how hydroponics sort of became what it is, it allows you to study plant nutrition, for instance, without having the complicated soil medium, and then it became commercial, applicable commercially, I should say. Aquaponics could do the same thing for us as far as mycorrhizal bacteria and bacteria that are associated with the rhizosphere without the complicating soil medium, and then we could learn things from soil production. I hope that's not too strange to say, but I think that that's sort of the direction some researchers are going in.
Yeah, I was just thinking about the fish too. Like, if you use tilapia, one kind of tilapia, they'll have their own microbiome. And then if you feed them a little bit differently than other people would, it'll change again and it'll affect the plant.
Absolutely. And that's a very dynamic system. Yeah.
Yeah, I know one lady, it's funny, she uses goldfish for some odd reason at her farm at home. Again, probably totally different. So yeah, there's a lot of factors there to look at, right? And there's a huge matrix of possibilities of what to do.
No doubt. And we have folks on our team, on our research team, that are looking at that, looking at the, positive and negative microbial actors in these systems and how feeding rates and feeding materials sort of affect those. And then, like you said, between the fish species, there's just sort of endless numbers of things we could look at.
Yeah, and you could, let's say you use tilapia, you could feed them certain things during the vegetative phase of the plants that they interact with, and then during the, I don't know if you call it fruiting, but when they actually produce the vegetables, maybe you feed them something different to accentuate that.
Right, and I've heard that talked about a little bit. I think it becomes, obviously there's challenges there in management that becomes very intensive. But there's also this talk of one thing that we're interested in with aquaponics. Again, this is outside of my particular realm, but I am interested in it, is sort of designing fish feeds for aquaponics. And those fish feeds, what they would do is they would have what normal fish food has in it, but also some added nutrients for the plants. In other words, the the fish don't need those nutrients, but the plants do, so we might as well add them into the fish feed. And there is some work being done on that. I think it's just, the question is aquaponics, as it develops as a technology, it needs to be profitable for the fish producer first, because it starts with the fish, and then we can sort of work our way. So getting that profitability on the fish side is the number one challenge, I would say. And then after that, you could see where you would have designer diets for the fish that would then lead to better production in the plants.
There's a lot to look into.
Yeah.
So in the aquaponics system, I know I haven't asked you much about aquaponics, but what are some of some of the ways to optimize an aquaponics system that you've discovered by running them there?
Oh, yeah, that's a good question. So as a horticulturist, I come at it from a slightly different angle than maybe other folks that do aquaponics. And I think that's, in some ways, that's a benefit, right? So it's kind of a different way of looking at it. We're oftentimes, myself and my students are thinking about how do we sort of take the fish effluent and use it to the best of our ability for the maximum, sort of benefit of the plants. And so because of that, I'll just say first and foremost, as we have started developing systems, we're very interested in this idea of, you could call it decoupled or on-demand aquaponics, and that's what we do. We take fish wastewater and then we use it appropriately for whatever system it is that we want to use. And so we don't have to have this constant recirculation between plants and fish. And so one of the benefits, we're about to submit a paper on this actually, we've looked at how long can we recirculate this water from the fish. And there's different names for this. They call it like loop systems and multi-loop systems, but we take the original fish effluent. It's been, a lot of the solids have been removed, not all. That's very important, not all. And the microbes have done their work on it. It's been filtered. Comes to us, and then we use it in multiple loops. So we might use it in an NFT system, for instance. How long can we keep it there until we have to replenish before we sacrifice yield? And that's a really important question for these types of systems as they develop. Can we run this water through a primary crop, then a secondary crop? That's something I'm interested in. In other words, every level that we move this water to gains efficiency to the overall.
Oh, that's right.
Yeah, and if we can do that without sacrificing yield, that's what leads to a better system design.
Yeah, also too, as the as the crops grow and as they go from the vegetative state to the flowering and then fruiting, their nutritional needs will be different. And I guess they would take different things out of the effluent. So when that gets recirculated back to the fish, what if that causes them distress or some kind of problem? It allows for the buildup of things that weren't there before, let's say, where there's a depletion of some kind of nutrient that they need.
Yeah. I haven't thought of it in exactly those terms, but that's a perfect illustration of how complicated these systems can be. So I think the way I kind of pitch it to people is, what we need to have for aquaponics to be really successful is you need to have a sort of well-run, profitable aquaculture business. In other words, fish production, right? You have some sort of market. Maybe you have a high-value fish. You can do it in tanks. Then you pair a horticulture system or a hydroponics-like system next door to it and share water. It has to start with a fish. Otherwise, we would just go straight to, commercially speaking, we would just go skip the fish and go straight to hydroponics. So like you mentioned before, there's a lot of challenges when you're trying to put two different types of species together that have very different requirements. The plant nutrients needs change. The fish, they age and they change. And so figuring out a way to simplify that system, and I think decoupling them or keeping them on demand in some ways independent of each other, not independent fully, but in some ways separate, is very, very important. Plus, the main thing is they need different environments to be in. The fish don't, for instance, the tilapia that we grow, they don't need light. They like very warm water. Well, plants need a lot of light and they don't want a lot of humidity. So I always stress, don't put your fish tanks in your greenhouse with your plants. Keep them separate. And that will help your plants and it'll help your fish as well.
Oh, why? The water that evaporates off the tanks makes the greenhouse too humid?
Right. Yeah. So, again, coming at it from a horticulture angle, I think I have a slightly different lens on this, but, there are four main factors for plant health in a greenhouse. It was going to be your amount and quality of light. That's one. then CO2, then temperature, and then relative humidity. So those are the four main factors that you need to control for. I mean, assuming you have water and nutrients that are optimal. So if you pull in, several thousand gallons of water into your greenhouse and you have that evaporative water loss, you're increasing unnecessarily the humidity levels. And sometimes it might help us, but most of the time it's going to hurt. Especially, again, my context, I'm in the Southeast United States, I'm in Alabama. Humidity is something that we fight against. And so we try to keep those large volumes of water in a separate location. So we have our fish currently at our setup, we have our fish in one greenhouse, and then right next door, we have our plants in another separate greenhouse.
Yeah, I was also picturing, if the fish need, or if they want very warm water, you might not be able to pump the water directly into the, the growing beds. You might have to maybe do like a waterfall in the air so that it cools down to a certain point before you put it into the plants. And then, but then you'd have cooler water going back to the fish, so you'd have to heat it up. So that could create a problem too. It
could. And then, the most successful aquaponics operation that I currently know of, and again, I don't know what their books look like, but they're growing, it's called Superior Fresh. It's up in Wisconsin. They're growing salmon. And, salmon needs cool water, but they're also coupling that with a lettuce production. Well, so in other words, it's the flip opposite of what you just said. The fish need cold water and the plants need warmer water. And so there's that separation. That separation allows for that temperature modification to happen over time. And of course, they keep their fish in a controlled environment. It's not even a greenhouse. It's just a separate room altogether, a separate building. And then they have greenhouses for their plants. And I really think that's sort of the direction we're headed in as the industry develops.
Yeah, even if you were able to do a system that cooled the water and then heated it or vice versa, who knows what that would do to the bacteria in the water too? It might stress them to death. Yeah.
That's a good point. It can go back and forth. It is. And when you start thinking about it, you go, wow, this is so complicated. I would say though, that is commercially speaking. So that's what my program and my group, we're kind of looking at is how do we commercialize this stuff? Because again, it is complicated, but we have a pretty good understanding of how you do aquaponics, and you can do it in your backyard. Tilapia, you mentioned your friend with goldfish. There are systems that have been developed. I would say that the standard system is what's called the UVI system, which is University of Virgin Islands system, and it works really well. It's sort of coupled together. There's lots of literature out there on it, and so if someone is a small producer or a backyard hobbyist or something, I would start with the UVI system and go from there. And it's relatively well established how it's done. The questions that we're trying to answer is how do you take this to a commercial level and make it sort of profitable at a commercial scale? And that's a tougher question.
Yeah. What kind of crops have you seen successfully grown with aquaponics, and which ones just don't work for it for some reason?
Oh yeah. So good. I'm glad you asked. So there's four big ones, and we keep kind of coming back. When I teach my classes, we come back to the same four over and over again. It's going to be tomatoes, cucumbers, peppers, and lettuce. And it's kind of funny because people will say, well, can you grow melons? And I'll say, yes. And they'll say, okay, can you grow potatoes? And I say, yes. You can grow almost anything in these systems, right? The question is, can you do it and have marketable product and be profitable? And it turns out that the four big ones are the ones that continuously become profitable for people at different places at different times. Those four remain. In fact, when hydroponics first started, it was a research tool. They used to call it nutriculture, basically plant nutrients dissolved in water used to study plant nutrition. And then a guy named W.F. Garrick, he was a researcher at University of California back in the 30s and 40s. And he coined the term hydroponics. And then he helped the U.S. military in World War II establish a little hydroponic test farm to produce fresh food for the military folks that were in the South Pacific fighting the war, to help them grow their own food, which they couldn't grow on these volcanic islands. And the four crops they grew were tomatoes, peppers, cucumbers, and lettuce. And I know I keep saying them in different orders, but again, it keeps coming back to the same four.
Yeah, well, that's boring. Who wants to only grow those four? You got to grow other stuff too,
Yeah, I agree. So if you're a homeowner, and you're interested in doing, if you're a hobbyist, I mean, go for it. Go grow anything. It's sort of like gardening. I teach an organic gardening class, and you grow anything, go crazy, experiment, do different stuff. But it seems like commercially, those are the four that are most successful.
So what's for people that want to dip their toe in and start either hydroponics, aquaponics, something? What would be a really simple setup for people so they don't get overwhelmed and so it's not difficult for them to start?
Oh yeah, that's a great question. I mean, I think that a floating raft or a deep water system is easy, inexpensive. You can buy everything you need at your local hardware store to get started, except for the seeds and the substrate. But as far as structure goes, and hydroponics is relatively simple. You can buy, water soluble nutrients. You can find nutrient recipes online. You can find specifics for lettuce or whatever it is, basil or whatever crop you want to grow, and start there. Now, as far as aquaponics goes, what I would do is start with a fish tank and maybe start with a deep water lettuce bed, and I would grow them separately. In other words, I would feed fish and try to learn how to grow fish. And then I would try to learn how to grow my vegetables using hydroponics. And then eventually, when I get successful at both, pull them together in some way and start using fish water to grow my vegetables. But I think what happens sometimes is that people say, wow, I'm going to go for it, full on. And they just go big. And then it doesn't work the way they think it's going to. And they sort of look at it as a failure. You have to sort of ease your way into it as a hobbyist for sure.
Yeah, definitely. So what major questions are you trying to answer right now with your research looking forward?
I think the big question with let's take aquaponics for now. We can talk about the others in a second. I think the big question for aquaponics is, can we be profitable? I mean, we know we have yields that are comparable to commercial hydroponic yields in our systems, and that's good. We can grow the same types of things that you grow in standard greenhouses. That's good. We can successfully grow tilapia, and that's maybe not so good. And the reason I say it is there's nothing wrong with tilapia. Tilapia is a fine fish. I've eaten tilapia right out of our fish tank several times, and it tastes very good. But it has a relatively low demand here in the United States. People don't eat a lot of tilapia. It doesn't command a super high price. I think the biggest challenge in aquaponics is growing a profitable fish species first. All right. So once we can get a profitable fish species, and there's several candidates out there, then can we make a sustainable aquaponics system sort of revolving around that? And so my research objective as a horticulturist is to figure out if and when we can do that, what are going to be our options for plants. And where I'm headed with this is that I think that it seems like saltwater or even maybe brackish water species are more promising in this area. Think about redfish, snapper, the flounder. There's a big list of them that are, quote, brackish water fish. So it's low salinity.
But then wouldn't you have to run the effluent through a desalinization type thing and then resalinate it, like put the salt back in?
Yeah, exactly. So that's where the challenge. So if you have, even if it's low salinity for fish, it'd be high salinity for plants, right? So our challenge as horticulturists is to figure out how we could potentially use this high salinity wastewater now, or high salinity for plants again. We have some ideas. We have tested these ideas, and a couple of them work really well. Obviously, one way you could do it is dilute. You could dilute the water, but then you're diluting your nutrients, and that's a problem. So what we're currently working on is a system where you don't have to dilute the water. You just have to provide enough fresh water in another capacity for the plants. It's kind of a complicated way of thinking about it, but we are splitting the root systems essentially. And so far, we've had really promising results, and we're getting ready to sort of push forward with that. And, we're still working out the kinks. Don't get me wrong, but there is some precedent for this working in other fields. And it's sort of like the hydroponics. Nutriculture was used to study plant nutrition, and all of a sudden it became commercially viable. Splitting plants roots systems works to study certain phenomena in plant water and nutrient uptake, but maybe it has a commercial application, and I think it does.
Okay. Any other Yeah, I'm sorry I interrupted you, but any other major questions that you're looking to solve with your research? I know there's endless things to do, but
yeah. Well, it's interesting. I mean, we do have vertical farms here on campus, and I use those more as a teaching project. And we have a fantastic partnership with our campus dining folks on campus. And so we produce food in our vertical farms that then goes to campus dining facilities. Again, more of a teaching project, but everybody and their brother is doing light recipes in indoor farms. You can manipulate light, ratios, blues and reds, and the other spectra, far reds. There's a lot of work being done on this to manipulate plant quality, nutritional value, for instance. Sort of shied away from the light research because so many people are in it. But that is definitely an area where I see a lot of potential, lighting recipes. And then indoor farming in general. We haven't talked much about it, but all of a sudden you can completely control the environment. It gives you maximum predictability. It helps you, open up new markets. And I think there is some promise there. It's not without trade-offs, but there's certainly some promise there.
And one last thing is, if I want to grow stuff and I need help, do I talk to an agronomist, a horticulturist, a gardener, a farmer? There's all these terms, and I don't know who does what and who focuses on what.
Man, that's a fantastic question. So I would say if you can't find a grandmother who gardens and you want to garden, then the next best thing is to look up your local extension agent. And I'm not an extension person, but we have extension agents that work directly with us at the experiment station, and they take, information out to folks. They're like sort of subsidized consultants, if you will, and they specialize. So there'll be a home grounds, extension specialist in your state, in your county, somewhere in the United States. And so those folks are really good resources. When I want to know how to do something, just to be honest with you, I YouTube things. YouTube seems to be a fantastic tool, but I would say take some of it with a grain of salt. But, in seriousness, extension agents are fantastic sources of information. They can get you sort of home gardening strategies, and you can find specialists in hydroponics as well.
They call them extension agents? Why?
Extension, yeah. So we're part, Auburn University, where I work, is part of what they call the land grant system. And there's what they call a tripartite mission. The land grant universities is research, instruction, and extension. And so, research and instruction, I think that's intuitive. Extension would be taking knowledge that is sort of learned at the university or elsewhere and packaging it for just the general consumer. So it's taking that knowledge, either it's directly to a farmer or it's to a hobbyist or someone who's just interested. So it's sort of extending the knowledge. That's why it's called extension.
Okay. Well, very good. What's the best way for people to find out more about your work in particular? Where can they go?
Yeah. So my website is currently being updated, but the best way to find me and to find out more about our department and the things that we have going on is to just, I can't remember all the extensions. I would just Google search Auburn University Horticulture, and you'll find all kinds of information, links to my personal website, or my faculty website, that is. And then I think there's information about different programs that we have and different faculty members. My information is there as well. Our aquaponics group has a website. You can search for that as well. Again, I can't remember all the extensions because they're kind of long. And then I would say another website that people might be interested to see that I just think is fascinating. We only touched on it very briefly, was the Culinary Science Center here at Auburn. We're operating a rooftop garden there. I'm really excited about it. And it's the Rain Culinary Science Center at Auburn University.
Oh, very cool. Okay. Well, Daniel, thank you so much for coming on the podcast and answering this blizzard of different questions. I appreciate it.
All right. Thanks, Richard. I appreciate your time.
Before you go, make sure to protect your smile from teeth grinding and clenching with a Remy custom night guard. Visit shopremy.com to get yours now and take an extra 20% off your order with the code GUARD20 at checkout.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at FindingGeniusPodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.